Right. Now, as we have seen the canonical standard forms and the min terms and the max terms, so if we have got a function which is not completely in the term, it's not representing all the min terms or the max terms, we can actually convert that into a function that we can identify all the min terms or the max terms. Okay, so in order to derive the sum of min terms or the max terms, we have got two methods. Either we can use the truth table like we have done in the previous ones and identifying all the min terms and so on, or we can use algebraic manipulation. And now I'm going to show you both accordingly. So if you look at the function e, over here as an example is given, y prime or x prime z prime. Now, this function, by using a truth table method, let's use truth table, we can actually have three inputs x, y, z and output as e. So 3 input means 8 possible combinations. One, 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 0 to 7. So we need to identify where this function is outputting 1. So this function is outputting 1 when y is equals 0. Y prime means y is equals 0. So y equals 0 at this point, no matter what's happening, it will output 1. Okay, so the y prime is giving us an output e as to be 1, or there's an or over here, it's going to be x prime and z prime. So where both x and z to be 0. So x and z is 0 over here, x and z is 0 over there. And we don't have any other. So we just need to add another 1 only here. So either y is equals 0 or x and z is equals 0, the function e is going to output 1. Okay? And the rest are just zeros. So as you can see, now we have got all the ones for E. We can easily write this as x prime, y prime, z prime, which is min term 0, x prime, y prime, z, which is min term 1, x prime, y, z prime, which is min term 2, x, y prime, z prime, which is min term 4, and x, y prime, z, which is min term 5. So now we can see that we have got all the min terms required for function e. And I can rewrite function e with these min terms as x prime, y prime, z prime, or x prime, y prime, z, or x prime, y, z prime, or x, y prime, z prime, or x, y prime, z. And I can also say E has got the sum of the min terms 0, 1, 2, 4, and 5. Okay, so this is a truth table method of finding the all the min terms for that function. We can also do this using algebraic manipulation, which I will show you next. And we will see that we are going to get the same number of min terms and the same min terms. Okay, the same expression, E equals y prime or x prime z. Now, x prime z prime. Now, in the homeworks or in the exams, if I don't specify a method to use in order to find all the min terms, you can either use a truth table, which I already done, or you can use an algebraic manipulation, which I will show you now. But if I specifically say that, okay, use algebraic manipulation to derive the sum of the minterms, you have to use algebraic manipulation. Okay then, so let's start with this function as it is not in a proper sum of product form. We have to put this into a proper sum of product form first. What do we mean by that? If you look at this part, it's missing y. If you look at this part, it's missing x and z. So the first thing to do is we have to include these missing variables in each term by applying the identity law. So what is identity law for sum of products? It's x plus x prime will always give you 1. Okay? Now, what is this missing? It's missing x and z. What is this one is missing? It's missing y. So the left-hand side of the OR and the right-hand side of the OR. Okay then. Let's start with left-hand side of the OR. We have got y prime, and what we are missing? X and z. So x plus x prime that we are going to include, and z plus z prime. This is like 1.1, right? So we can include those in. And if we do that, so this is going to be like multiplying these out. Okay? So this is going to be x, y prime, or x prime, y prime. And then that will be multiplied with z plus z prime. And this is going to be x, y prime, z, or x, y prime, z prime, or x prime, y prime, z, or x prime, y prime, z prime. Okay? So we have included all the terms for left-hand side. If there are similar terms, we can just eliminate those terms. Okay? So for example, do we have any over here? I don't think we have got any similar. Okay, then we do the same thing for the right hand side, which we need to include x prime, z prime. What are we missing? Y plus y prime. And this is going to be x prime, y, x prime, y, z prime, or x prime, y prime, z prime. Now I have got the right hand side and the left hand side, both has got all the variables that we have got in the function. And if we combine these and rewrite it, so I'll start from here, x, y prime, z, or x, y prime, z prime, or x prime, y prime, z, or x prime, y prime, z prime, or I'll write these ones, x prime, y prime, z prime, or x prime, y prime, z prime. Now I can easily see that these two are equal. So if I have got similar functions, I don't need to rewrite them. I can just get rid of one of those. And if I rewrite the expression with the new x, y prime, z, or x, y prime, z prime, or x prime, y prime, z, or x prime, y prime, z prime, or x prime, y, z prime. Now let's check which minterms we have covered. 1, 0, 1, then 1, 0, 0, then 0, 0, 1, then 0, 0, 0, and then we have got 0, 1, 0. So this is minterm 5, minterm 4, minterm 1, minterm 0, and minterm 2. You can just read them as the binary numbers. So I can say that I don't have space over here, but I'll try my best to fit in. Some of the minterms, are 0, 1, 2, 4, and 5. Okay, so I wrote 4 and 5 as 5 for both. So 0, 2, 4, and 5. Now, if I check the truth table version, 0, 1, 2, 4, 5, 0, 1, 2, 4, 5. So by using algebraic manipulation, I got the same answer. Okay, so include the missing variables, get rid of the similar ones, and write the expression. That's all you need to do. So for the min terms, the identity is always x plus x prime, which is equals 1. That's how we are including those missing variables. Now, we can do the same function for the max terms. Now, for the max terms, I'll just show you quickly what we have done so far. The min terms by finding out from the truth table and by using algebraic manipulation step by step, get rid of that, and 0, 1, 2, 4, 5, you'll get the same thing that we have got over here. And for the max terms, if you want to find out the max terms, again, the same function, nothing is changing over here. If you plot the truth table, we know where it is 0, right? When we are doing the truth table. So we have got zeros at these points. Okay, so we can easily write those. Okay, so this is how it is going. And we have got is apart from the ones, we have got 0. So this is M3, M6, and M7. And in order to write those, we can write it as the max term form, which is x plus y prime plus z prime, then x prime plus y prime plus z, and then the last one is x prime plus y prime plus z prime. And that will give us the max terms. How about algebraic manipulation? That's a little bit tricky compared to the truth table method. And we are going to see that as well. So first of all, I am going to write the function again, y prime plus x prime z prime. Now, before I put this into the missing variables and reorganizing the equation, I have to convert this into a max term form. So what is that max term form? I have to write these as product of sum. So how do I write that in product of sum? This is like multiplying out these terms, like we have done it before. So it's going to be E is equals y prime plus x prime and y prime plus z prime. Now this is in product of sum form because we are product multiplying the sums with this expression. Now I can easily include the missing variables into these. But at this time, rather than using x plus x prime, the identity for POS is going to be x dot x prime, which is equals 0. Okay, so that means if we move further down over here by including the missing variables, y prime plus x prime, then this is going to be, what is missing? Z is missing, z dot z prime. And then the other one is y prime plus z prime plus x is missing, x dot x prime should be there. And then this will be expanded now. It's going to be expanded as y prime x prime plus z, y prime plus x prime plus z prime. Two separate of those, and this one has to be extended, y prime plus z prime plus x, and y prime plus z prime. I think I cannot fit it. I'll write it down. Over here, y prime plus z prime plus x prime. Do we have any identical ones? If we have got identical ones, we can get rid of those. So if we look at it, this one and this one are identical. So if I get rid of that, I'll just have E as y prime plus x prime plus z, y prime plus x prime plus z prime, and y prime plus z prime plus x. So what are those? This is 1, 1, 0, which is 6. This is 1, 1, 1, which is 7. And this one is 1, 1. I think I mixed up one. So x prime, y, z, x prime, y prime, x prime, z, y prime, x prime, z prime. Okay. Z, x, yeah, y prime, z prime, x. Okay, sorry, I have got this other way round, I guess. Yes, so this is going to be 1, 1, 0, but as x is in the far end, this is actually 3. It's 0, 1, 1. Okay, so that means our max terms are going to be 3, 6, 7, like we have found in the truth table. Okay, so that's how we can find out the min terms and the max terms of the functions, either using a truth table or as a algebraic manipulation. And again, the steps are showing it over here, and we can easily find out and introduce the missing variables and find out the max terms, either with the truth table or with a algebraic manipulation. And another important thing in the functions, so sometimes we have got incompletely specified functions where the output can be either 0 or 1, it doesn't matter. And at this point, if it doesn't matter, we can just put x rather than 1s and 0, any specific values. So by adding x's into the outputs, we can actually make an assumption when we want to simplify an expression. So for example, case A, where we have got 0, 0, 1 as x, we can assume that as 0, and 1, 1, 0 and as 0 as well. So when we write the sum of product, we just write where it is 1. So A prime, B prime, C prime, A prime, B, C, and A, B, C, right? So these are where we have got 1s, if x's are 0s. Then that's going to be, so I can do this over here just to show. So f, based on that, A prime, B prime, C prime, which is this one, then or A prime, B, C, and then or A, B, C. If I use algebraic manipulation, what I can do is, these are similar, BCs. So A prime, B prime, C prime, or I can take BC out, A prime plus A is left inside. This is going to be 1. Then A prime, B prime, C prime, or BC is my new expression. Okay, so this is how far I can go when x's are both zeros. Now in case B, as you can see, if this x is assumed to be 1, then I have to write that one as a min term as well, and this is a 0. So that means I'm rewriting it A prime, B prime, C prime, and assuming that is 1, or A prime, B prime, C, okay? And then this one, A prime, B, C, and then A, B, C. So I have got those now. So 0, 0, 1 is 1 and 1, 1, 0 is 0. Okay, so let's see if I can simplify this further. Once again, I can take this one. So A prime, B prime out, C prime plus C. And on this one, I can take BC out and I say A prime plus A. This is 1, this is 1. And all I left is A prime, B prime, or BC. So as you can see, when you compared these two expressions, this one has got 3 inputs, AND gate, and 3. This is AND 3, this is AND 2, and this one has got AND 2 and AND 2, and of course OR 2. So as a literal wise, this one, as a literal wise, this is simpler, as we have got less literals over here. Less literal means less interconnect at the wire. So we prefer to use this one. So as you can see how x's are actually affecting the equation. So we have to be really careful how are we going to make this assumption. Either x is 0 or x is 1. So we have got a couple of exercises related to these, like simplify the following Boolean expression to a minimum number of literals. We can use algebraic manipulation over here. So A is A, B, C prime, or AC. Now, how can I simplify that? A is common. I can take A out. This is B, C prime, or C. Okay? Now, this can be multiplied out. So A is there, B plus C, C prime plus C. This is 1. This is A, B plus C, which is going to be AB plus AC. Okay? This is A. Then we can try B. Now, this is A prime, B prime, D, or A prime, C prime, D, or BD. Now, how can we implement this, or what can we do about this? As you can see, D is common. So we can take out D, A prime, B prime, or A prime, C prime, or B. Now we have got D out. A prime, and so on. Now this is, what can we do on this? So by these two, we can actually have D over here, A prime, B prime, I'm just rearranging it, plus A prime, C prime. Now, this one is going to be again distributed. Maybe I can change the color. So D is going to be A prime plus B, and B prime plus B. So this is gone, plus A prime, C prime. And this is going to be D, A prime plus B plus A prime, C prime. Okay, so we have got a new expression, and as A prime is over here, I can again rearrange it. So A prime plus A prime C prime plus B. And this one, A prime is common. It can be taken out. 1 plus C prime is there plus B. So that's gone. And we have ended up with D as an outside, A prime plus B. And that will be the most simplest version of it. And the last example related to this, we have got C as A prime plus B prime, B, and the prime is outside, dot A prime plus C prime prime, dot A, B prime, C prime. Now, if we take the De Morgan of that, this is going to be A, B prime, and that's going to be A, C, and this one is going to be A prime plus B plus C prime. Now, this one is actually what? This is actually A, B prime, C, and that will be A prime plus B plus C prime. And this is actually showing us that this is opposite of that. So they are canceling each other, and this is going to be 0. So that's how we can implement part C of this exercise. Now, another exercise, we have got De Morgan. So if we want to take the De Morgan of that, A prime or B or C prime, so then that's going to be A plus C and then the prime, and it's going to be A prime or B prime and the prime. So we have got a De Morgan expression for that. If you have any questions, please note those down, or if you have anything that you couldn't understand, note them down and please do ask me.